radiation with thickness of solution is directly proportional to the intensity of the incident light as well as the concentration of the solution. So if I being the intensity of the incident radiation and X being the thickness of the solution and C is the concentration of the solution, then the Beer's law could be written as the decrease in the intensity with respect to the thickness is directly proportional to the concentration of the solution and intensity of the incident radiation. So on integration, we arrive like ln I by I naught is equal to minus k dash C into L. And after introducing log etc., finally we arrive at A is equal to epsilon C L, and this is a mathematical expression for Beer's law. And again, epsilon is molar extinction coefficient. We have relationship between the absorbance and transmittance, like transmittance is equal to, it is just the inverse of absorbance, or in other words it is minus log of transmittance, which is equal to log I by I naught. Okay, from the equation it is seen that the absorbance, which is called as optical density of a solution in a container of a fixed path length, is directly proportional to the concentration of the solution. So to conclude, we have discussed about what is spectroscopy, what is electromagnetic radiation, the principles that were involved in spectroscopy, interaction of electromagnetic radiation with matter, and the photophysical laws like Beer's law and Lambert's law. So these are the resources